Imagine looking up at the night sky. You see the moon, a familiar friendly face. You see the stars, tiny pinpricks of light, trillions of miles away. But tonight something is different. Something is new. A new star has appeared, one that wasn't there last night. It's brighter than any other star. Night after night it grows larger. It's not twinkling like a star. It's shining with a steady, menacing light. Soon it's as big as the moon, then bigger. It's no star. It's another world, a rogue planet hurtling through the dark emptiness of space, and it's on a collision course with us. This is not science fiction. This is physics. And it's coming right for Earth. This visitor isn't just a rock. It's a world, perhaps as large as Mars or even Earth itself. At first it would be a wonder of the world, a celestial spectacle unlike any seen in human history. Every telescope on the planet would be pointed at it, tracking its journey. Scientists would be in a frenzy, calculating its path, its speed, its composition. How can this happen? Aren't planets supposed to stay in their own lanes? To understand, we have to pull back our perspective, zoom out, way out, past the moon, past the other planets, until our whole solar system looks like a beautiful, spinning machine. In this machine, the sun is the giant, glowing engine at the center. Its immense gravity is like a powerful, invisible leash, holding on to everything around it. All the planets, including our Earth, are caught in this gravitational grip. They are constantly falling towards the sun, but they are also moving sideways so fast that they keep missing it. This sideways motion and the constant fall create a stable path, a cosmic racetrack we call an orbit. Think of it like swinging a ball on a string around your head. Your hand is the sun, the string is gravity, and the ball is a planet. As long as you keep swinging, the ball keeps circling. It doesn't fly off into space and it doesn't crash into your hand. It's in a stable orbit. Every planet in our solar system is doing this same dance. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, each on its own string at its own distance, moving at its own speed. They've been doing this dance for over 4.5 billion years. Their paths are clear, predictable, and most importantly, separate. So, what could possibly knock a planet off its stable, predictable path? How could two worlds be set on a collision course? It's all about gravity. Gravity isn't just a leash, it's also a force that can push and pull in unexpected ways. Imagine our solar system is a perfectly balanced mobile. Now, imagine another star. Drifts too close. The gravity of this passing star would be like a giant hand shaking the mobile. The delicate balance would be broken. Orbits could be warped, stretched, twisted. A close pass by another star is a rare event, but the universe is a very old and very big place. Over billions of years it can happen. When it does, the gravitational chaos is immense. Planets could be thrown into new, wild orbits. Some might be flung out of the solar system entirely, destined to become those lonely rogue planets we talked about. Others might be sent careening inwards, towards the sun. And some, just maybe, could be put on a new path that intersects with another planet's orbit. A cosmic game of billiards where the cue ball is a star and the planets are scattered across the table. There are other, more local ways for orbits to go wrong. Even within our own solar system, the giant planets like Jupiter and Saturn have so much gravity that they can nudge the other planets around. Their gravitational influence acts like a subtle, constant pressure. Over millions of years, these tiny nudges can add up. They can slowly alter a planet's orbit, making it more elliptical or tilting it. A small change now could lead to a catastrophic intersection millions of years in the future. It's a dynamic, evolving system. And then there is the most direct possibility. A rogue planet from interstellar space simply wanders into our neighborhood. It's not from here. It doesn't follow our rules. It's a stray bullet fired from a distant galaxy eons ago. Its path is a straight line through our solar system, and if Earth happens to be in the wrong place at the wrong time, a collision becomes inevitable. It's an event of pure cosmic chance. A 1 in a trillion shot. But in a universe with trillions of worlds and billions of years, even the most unlikely events are bound to happen somewhere, sometime. Let's return to our nightmare scenario. The rogue planet is here. It's no longer a distant object, it's a world filling our sky. In the final days, its gravity would wreak havoc. The pull on our oceans would create tidal waves miles high, sweeping across continents. The strain on Earth's crust would trigger constant magnitude 10+ earthquakes, leveling every city on the planet. The ground itself would ripple like water. Volcanoes on every continent would erupt in unison, choking the atmosphere with a thick black veil of ash, sulfur. The sun would be blotted out. Day becomes a permanent, terrifying twilight. The two planets enter the Roche limit. Tidal forces, the stretching effect of gravity, overcome a planet's own gravity. The smaller or less dense world begins to be torn apart. Imagine our moon getting too close to Earth. It would be shredded into a spectacular ring of rock and dust. If the visitor is larger than Earth, our world disintegrates. Our beautiful blue marble is ripped to pieces before collision. If they're similar size, both may break apart. Huge chunks of crust, mantle, mountains bigger than Everest, get lifted off and pulled into space between the worlds. Our atmosphere is siphoned away, sucked into the void, or pulled onto the other planet. The air thins until it's gone. The sky, already dark with volcanic ash, fills with a river of glowing rock and debris between the planet's final scream, a torrent of its own substance being torn from it, the moment of contact. Not two billiard balls clicking together, a slow, grinding, unimaginably violent merger. Crust buckles and vaporizes at impact, energy released, staggering millions of times greater than all nuclear weapons combined. The impact point flashes brighter than 1,000 suns. A shockwave races through both planets, turning solid rock into a sea of molten lava. The collision is silent in space. On the surface, the roar of a world ending is absolute. So what is this incredible power we're talking about? It's called kinetic energy. A moving car has kinetic energy. A thrown baseball has kinetic energy. And get this, a planet weighing like 6 trillion kilograms and moving at over 67,000 miles per hour has a colossal amount of kinetic energy. When two planets collide, all of that energy has to go somewhere. It doesn't just disappear, it's converted, mostly into heat. An unbelievable, unimaginable amount of heat. Enough heat to melt the surface of the planets, enough heat to melt the entire planets themselves from the crust all the way down to the core. Think of it this way. When you rub your hands together, the friction from their movement creates a little bit of heat. Now imagine your hands are the size of planets and they're moving at thousands of miles per hour. The heat generated would be enough to turn solid rock into glowing, vaporized gas. The collision would instantly create a temperature of tens of thousands of degrees, hotter than the surface of the sun. Both planets, Earth and its aggressor, would cease to be solid worlds. They would merge into a single giant seething ball of liquid rock, a new world born from the fire of two old ones. It would fundamentally change their motion. A head-on collision could bring both planets to a screeching halt in their orbits. Their forward momentum would be cancelled out. What happens when a planet stops moving sideways? Remember our ball on a string? If you stop swinging it, it falls directly toward the center. Without its orbital velocity, the new molten superplanet would have nothing to stop it from falling directly into the sun. The end of the Earth would be followed by its final journey into the heart of our solar system, to be consumed by our star. But hey, what if the collision is a glancing blow, like two spinning tops bumping into each other? The impact would send them both spinning wildly. The length of a day on the newly merged planet could be just a few hours long. The collision could also knock the new planet into a completely different orbit. It might be sent into a long elliptical path that takes it close to the sun and then far out into the cold depths of the solar system. Or, it could be knocked into an orbit that is tilted, way off the flat plane where the other planets travel. The old, predictable clockwork would be shattered forever. In the aftermath of the collision, there are no survivors. Not a single microbe. Not a single blade of grass. Life, in all its magnificent diversity, would be extinguished in an instant. The oceans would boil away, the continents would melt, the very ground we stand on would become a glowing sea of magma. The story of life on Earth, a 4-billion-year epic, would be over. Shakespeare, Beethoven, Einstein, every human who has ever lived, loved, and dreamed, its legacy, a brief, shining moment in the cosmic darkness. There is no hiding, no escaping an event of this magnitude. What would this cosmic catastrophe look like? From the surface of Mars, the collision would be the brightest light ever seen in the sky, besides the sun itself. For a moment, it would outshine everything. Earth, our brilliant blue marble, the pale blue dot, would vanish in a flash of incandescent light. In its place would be a new glowing star, a fiery red ember where a living world used to be. An astronomer on a hypothetical Martian colony would record the event as the sudden death of a neighboring world. A final silent firework in the blackness. From farther away, from a moon of Jupiter or a moon of Saturn, the event would be less dramatic but no less profound. Through a powerful telescope, you would see Earth suddenly flare up, becoming many times brighter. Then, over the following days and weeks, you would see it change. A glowing ring of debris would become visible around it. The color of the planet would shift from its familiar blue and white to a dull, angry red. The observers would know a cataclysm had occurred, an entire world remade. They would be witnessing planetary evolution in real time. For any advanced alien civilization watching from a distant star, the event would be a tiny flicker. Their telescopes might detect a sudden brief spike in infrared radiation, a blip in their data, a momentary surge of heat. They might classify it as a possible planetary impact event. They would have no idea of the life, the history, the consciousness that was just erased. To them, a curious astronomical phenomenon, a footnote on a distant star. But for us on Earth, the view would be the end of all views. In the final moments, the sky would not be blue or black, it would be filled entirely by the approaching world, a ceiling of rock and cloud, so close you'd feel you could touch it. The final sunrise would not be our sun, but the glow of the planet's surface as it heated from tidal stress. The end would not come in darkness, but in a blaze of impossible, world-shattering light, the last thing ever seen, the ultimate and final spectacle. Planetary collisions seem like something out of a nightmare. They represent the ultimate destruction, the end of everything we know. But on a cosmic scale, they are not just about destruction. They are a fundamental part of creation. The universe is not a gentle, static place, it is violent, it is dynamic, it is constantly changing. Planets are not permanent, they are built, they are shattered, they are reformed. Our own solar system is the product of countless collisions. Every planet is a survivor of a chaotic and violent past. Every moon is a survivor. Every asteroid is a survivor. The formation of our own moon from a giant impact was a pivotal moment for life on Earth. The moon's gravity stabilizes our planet's tilt, giving us a stable climate over long periods. Without the moon, Earth would wobble, leading to extreme and unpredictable changes in weather that might have made it impossible for complex life to evolve. The very cataclysm that nearly destroyed the young Earth may have been the key that unlocked its potential to harbor life. When we look out into the cosmos, we see the evidence everywhere. Star systems with huge disks, clouds of dust, scattered debris, the telltale signs of recent planetary collisions. Planets orbiting in strange orbits, elliptical orbits, tilted orbits, likely the result of past gravitational chaos. These collisions are the hammer and chisel of the universe, sculpting solar systems. They clear out unstable orbits. They form moons. They deliver the raw materials for new worlds. They are a powerful and necessary force of cosmic evolution. It connects us to the grand story of the universe, to its violent story and to its creative story.